Hey everyone, we're the team working under the Surftech sponsor. My name is James Swope.
I'm Jonathan Janine.
Catherine Bitterly.
I'm Martin Still.
So we're working with Surftech, and so they kind of have two main design principles going on. So they work on original equipment manufacturing, where they are clients will come to them with a product and are like, how do we manufacture this? And they'll develop that process to develop their products on a large scale industrial setting. And then also original design manufacturing, which is more just like commercial product design. So like clients will come to them with specific needs and say like, hey, we need an Ethernet cable that does this, that, and the other, and they will design some sort of product that will help meet those goals. So here are kind of just some of their products that they work on. So they are mainly in the structural cables and telecommunications industry. So they work with a lot of Ethernet cables and like the connection jacks, as well as like wall plates of like where these actually like plug in. And then a lot of these are also for industrial settings, so they have to meet particular standards such as a 25-year warranty. And then also like the IP67 has to do with like water resistance and like dust resistance so that it'll last in particular environments.
Perfect. So just a little background on the problem we're working with. We're trying to balance out the profitability and market viability of injection molding to make it a more ecological practice. Just basic understanding of injection molding is you're injecting molten material into a mold, allowing it to dwell and cool, and then removing it from the mold and having a finished product. There's two main, worlds of goods that they're trying to produce: commercial goods, which is most goods that we work with, like polycaps, containers, computers, and then also industrial goods, where we're more focused on. And those specifically need to have that 25-year warranty that was mentioned before, and also meet some industrial scale applications just for whatever chemicals they're working with, whatever setting they're in, temperature gradients. But these kinds of products can be agricultural products, medical tools, or machinery components. So there's quite a wide range of injection molding world, or within the injection molding world. You can work with different materials such as metal products, electric equipment, or plastic components. Our main focus will be in plastic, namely PLA and ABS, which, given initial research, can be shown that on the far right diagram doesn't contribute to the most to the actual CO2 emissions of injection molding. It's mainly within the metal products, just given how much you have to heat and process it. So while there is seemingly limited capacity in how much you can improve the production process, we do think we can improve in the operating scale. So choosing different materials or working with materials that might be easier to process, easier to break down, take less time to work with is where we're looking forward to handling. But the two main realms is deciding which materials to work with or how to better work with them.
Our design objective is to reduce Surftech's carbon footprint by finding alternative materials or processing methods in the plastic production used in the structural cable and telecommunications industry. And the alternative materials and processing methods will be considered with carbon emissions and industrial products for design.
Okay, so like we mentioned, there's sort of two approaches. So when it comes to improving the industrial process, there is a lot to be gained, or potential that could be gained there, but it's a bit beyond the scope of what we are able to do in a semester, because this is sort of industrial scale equipment that might need changes or redesigns, and it's just not something we can get done this semester. More along what we can do as material science students is looking at changing the inputs for their products. So using either increased amount of recycled plastic, so adding in post-consumer products or post-industrial products to remelt and re-add to their new creations. One thing to keep in mind with this is that there is some degradation of plastics as you recycle them, and we do want to make sure that we keep meeting their high standards for performance because they have these higher industrial applications. As we mentioned, the 25-year warranty, they expect their products to last at least 25 years, if not longer. So that's something to keep in mind. The other thing we could look at is potentially changing what plastics we're using entirely and looking at this concept of infinitely recyclable polymers. So these are using cyclic ester polymers, and that reduces the amount they degrade as they're remelted and reformed. And so that means that they can be continually used even beyond the sort of expected lifetime of most recycled polymers.
So looking at how we're gonna go about like programming and working towards our end goal of having a finished product by the end of the semester, we put together a Gantt chart like most teams. We kind of outlined all the assignments that we had to do throughout the semester, as well as put periods in for research and actual testing of our products. Because this is such an open-ended question, we left a lot of time for research, because we would need to like adequately define good materials selection and good testing procedures to make sure that we are getting our materials up to the standards of certain types of industry. So these are kind of the rest of that Gantt chart. It was a great way to show it on one slide.
And that's it. Any questions?
Are you guys gonna be doing any injection molding?
That depends on sort of what we have available to us. We would like to be able to test, especially for like changing the plastics. We'd like to be able to see their performance in an injection molding environment, but I don't know if that's, like, is there injection molding available on campus? There is. Cool. So yes, then.
Yeah, I'll say, like, the scope of our project is still yet to be determined, in figuring out what exactly we will be working on, but I think it would be good to do injection mold, like, materials before testing them to kind of see how that processing affects the properties.
When we were talking with our sponsor, basically in the initial conversations, the project scope was, our goal is to be net zero by 2050. Do something to help us with that. And so we've narrowed